Hey guys, hope you're continuing to work hard and learn amid our continued shelter during the outbreak of COVID-19. One question I've gotten a lot about the virus is one you might have in mind as well, which is how do you kill it? I've heard a lot of potential answers to this question. Extreme heat is one of the common answers that I hear, from saunas to hot baths to hand dryers. Another answer that I hear is extreme cold, like ice bucketing or standing in a freezer. I've heard some people call out ultraviolet light, antibiotics, chlorine spray, saline rinses, which is like salt water that you like shoot up your nose. Eating garlic, the list goes on and on. So far, there's not really any science to support that any of those things are going to help combat infection from COVID-19. But the most important reason is that coronavirus, it just can't be killed because it's not alive. So bacterial infections are a little different than coronavirus. Bacterial infections include things like strep throat, tuberculosis, or other infections could be also caused by larger organisms like malaria or fungus. Malaria is actually caused by a protozoan, which is like a bigger cell than a bacteria, and then fungal infections are caused by funguses. Viruses are different because they're not actually made of cells, so they aren't really considered to be living. They can't reproduce on their own, and they can't do very many of the other things that living things can do, like obtaining and using energy on their own. Instead, they're basically just a little capsule with a tiny strand of DNA in it, and then it has the machinery to inject that DNA into our cells. That machinery lets the virus function kind of like a hacker. It can hijack the DNA of our own cells and then copy itself onto new cells. Some viruses are pretty much harmless, and we may even never notice that we have them. Other viruses don't really harm our bodies, but our bodies react to them, so we still have symptoms that make us seem sick. We might have a fever, we might start sneezing, we might have a cough. And then there are, of course, viruses that actually do damage to our cells by taking them over and making them multiply in a way that's not really what they're supposed to be doing. So to respond, our body has an immune system, and that system can attack the virus in a multi-pronged approach. So the key to each attack isn't actually about killing the virus, but really about destroying it and dismantling it and taking it apart brick by brick. Then, once that virus has been destroyed, you can isolate the cells that have already been hacked so they don't spread more copies of themselves. So white blood cells in our body, which you've probably heard of, will consume and eat the sick blood cells, basically making them digested and torn apart to bits. Blood temperature will also increase in your body, which will give you a fever, but it'll try to break the virus down by being a little bit warmer. Now, people have talked about exposing your own body to heat, but there's no way that you could actually heat the inside of your body enough without completely killing yourself. So you really don't want to make yourself have your own fever. It's better for your body to handle that business. And then you have things like mucus, which gets secreted in your lungs and can force out invading particles through sneezing and coughing. All of these different responses lead to the symptoms that we feel when we're feeling sick. So coughing, sneezing, fever, fatigue, that's actually your body defending itself. Unfortunately, that's pretty much it for the defense we can use against viruses. And sometimes that defense causes us to do more harm to ourselves and to our body, and can sometimes cause us to die, especially if that defense aggravates pre-existing conditions like heart conditions or lung conditions that somebody might already have. Once our body knows how to fight off a particular virus, though, and once it recovers, then usually the body can be immune to that virus because it can fight off future invaders of the exact same type. This is actually how vaccines work. They'll teach your body how to fight off a certain virus by showing your body the DNA that's in it, kind of like you reading a player's guide before you play a video game. Problem is that the viruses can mutate rapidly and often, and so the body's not necessarily going to be prepared for new versions of a virus. There are many kinds of coronavirus, many kinds of influenza, many other viruses which change so much that the DNA that we've read the first time might have changed in the new version. Medicines aren't really as powerful against viruses as they are against bacteria for the most part. Antibiotics can actually kill a whole range of bacteria unless they've become resistant to it, but viruses are really specific. So without a specific way to respond, there usually isn't one medicine that can take out a whole range of viruses. Usually they have to be targeted, and otherwise they would do a lot more harm to us than they would do to the virus. In addition, more or less like unlike bacteria, since they don't use energy, viruses don't really break down or die, even if they're left out on surfaces outside of an organism's body. There is actually some viruses that have been frozen in ice in like Russia and Greenland for tens of thousands of years since the Ice Age, and with all the climate changing that's happening there and the ice starting to melt and glaciers starting to recede, some of those viruses have been exposed, and they've tested them, and some of them can even infect organisms now, even though they're like 30,000 years old. The coronavirus, as far as we know, has been able to survive as long as 17 days on just like a surface without necessarily being destroyed. Now, obviously, that means that it hasn't been disinfected or something that would cause it to be destroyed through chemicals, but nonetheless, it means that it can survive for quite a long time, and we can't disinfect every surface that we ever come in contact with. So the key strategy is to keep a person alive and stable long enough for their own immune system to fight off the virus by taking it apart and by isolating any cells that have gotten mutated by the virus, and then to vaccinate any people so that they can't become infected with the virus later. Currently, we don't have a vaccine, but there are a lot of promising options, including some that might involve using a serum of people who've already built up the antibodies in their body to try to fight off the virus in other people's bodies. We don't know yet if that will last because there's some evidence that people who've been infected by the virus can get infected again, meaning that they're not really immune to it. So we don't know. It's a little too early, but stay tuned and keep reading the news about it. A lot of times advanced viruses like coronavirus don't evolve or mutate as quickly as really basic ones, and so vaccines can actually last longer and stay effective for longer if they are developed. So given how advanced COVID-19 is, the hope is that any vaccine we make now will last a long time. That's all about that. If you have any questions, let me know in the comments, and I will talk to you guys soon.